You want to get a handle on something complex quickly without feeling totally overwhelmed. Yeah,
That's the goal.
good. So today we're jumping into a really interesting AI puzzle. It's about knowing when an AI, well, knows its own limits. When should it maybe pause and say, hang on?
Exactly. It stems from some fascinating research looking at how AI models react when they encounter data that wasn't quite in their initial training or is different from it.
Okay, so this mission, if you like, for this deep dive is understanding how AI can spot situations where it might mess up, and maybe why getting this perfect is still a bit beyond our reach right now.
Precisely. We're exploring how AI can learn to sense when it's on shaky ground. When its training data just isn't quite enough for what it's seeing now. The study we're digging into set up some pretty clever experiments to see this happen.
All right, let's get into it. The basic idea is AI learns from data, right? But real life, it's unpredictable. It throws curveballs.
Mm-hmm. That's the core problem. That mismatch can lead to errors. And the really tricky part is teaching the AI to identify those situations itself to know when its training is falling short.
So how did this study test that? You mentioned specific AI models.
Yeah, they used two main models. Let's call them Model A and Model B. Think of them as two students.
Right.
Model A was trained to recognize 29 different types of things, like objects.
29 classes. Got it.
Model B got a broader education. It learned 47 classes. And critically, those 47 included the 29 that Model A knew, plus 18 extra ones.
Ah, so B knew everything A knew and then some.
Exactly. It had a wider knowledge base. And that setup right there shows you how the scope of what an AI knows really impacts how it handles something unexpected.
Makes sense.
Yeah.
So what happened when they showed them stuff that only Model B had learned? Stuff from those extra 18 classes.
Right, this is where it gets revealing. When Model A encountered these things it had never, ever been trained on. Well, it often gave really inconsistent answers.
How so?
Or it would make a guess, but with very low confidence, usually flagging below a 90% certainty level.
Can you give an example? Make it concrete.
Sure. Imagine showing Model A a banana, if it's never been trained on bananas.
Which it hasn't in this setup.
Right. It might try to label it as something it does know that looks, I don't know, maybe yellowish and curved, so it might say lemon.
Okay.
But, and this is key, it would likely do so with low confidence, say 70%, basically signaling, I'm guessing, but I'm really not sure. It often marked these as undefined.
And Model B?
Model B, having learned about bananas, would just say banana, probably with 100% confidence. Nailed it.
So that low confidence score from Model A is like a little red flag, a signal of uncertainty when facing something totally new.
It can be, yes, that's one potential indicator, but there's another wrinkle, overfitting.
Right, I've heard that term. That's when the AI learns its training data almost too well.
Exactly. It's like cramming for a test by memorizing specific questions and answers, but not really understanding the underlying concepts.
So you ace the exact questions you memorized, but a slightly different one throws you off.
Precisely. The AI focuses too narrowly on the patterns in its limited training set and then struggles to generalize that knowledge to real-world variations. It creates blind spots.
So sticking with the fruit theme, even Model B, which knows bananas, could get confused.
It could, yeah. The study showed this. Let's say Model B was trained mostly on whole, unpeeled bananas.
Okay.
Then you show it a banana that's been peeled and sliced. It's still a banana, obviously, to us.
Right.
But Model B might hesitate. It might look at the slices and say something like banana, cheese, or lemon, again with low confidence, flagging it as unknown. The presentation is different enough from its training data that it gets confused.
Wow. Okay. So even knowing the category isn't foolproof if the input varies too much. But wasn't there also a scenario where the AI was really confident but still wrong? That seems even trickier.
That was a fascinating part of this study. It really highlights the limits. They had a situation where multiple AI models, 9 of them, all like Model A, so none trained on bananas, were shown a banana.
Okay, 9 models, none know bananas. What happened?
They all agreed on what it was, and they were all confident. They collectively labeled the banana as a lemon.
All 9 of them, confidently.
Yeah, with an average confidence score of 92.3%, so well above that 90% threshold we talked about.
Whoa. So high confidence, even group agreement, doesn't guarantee correctness if the thing is fundamentally unknown to all of them.
Exactly. It's a critical finding. They were confidently wrong together. The video results mentioned in the study showed something similar. For a set of 30 test samples of unknown items, 27 were correctly flagged as undefined or uncertain.
Okay, so the uncertainty detection worked most of the time.
Right, 90% of the time. But 3 of them, 10%, were confidently mislabeled as lemon. It shows the system isn't perfect.
Which brings us back to the idea that we can't just instantly update an AI when it encounters something new. There's no magic learn this now button in the real world.
Not yet, anyway. Instant retraining isn't feasible in most applications, so a perfect system for knowing exactly when to pause, when to say, I don't have enough data for this specific situation, well, it doesn't exist currently.
So the research is more about finding better ways for the AI to flag its own potential limitations.
Precisely. It's about developing mechanisms like monitoring confidence levels or looking for disagreement between models that help the AI recognize when it should perhaps defer to a human or request more information.
So wrapping this up, the big takeaway seems to be that these discrepancies between carefully curated training data and messy reality really shine a light on AI's limits. It struggles to generalize beyond its specific training.
Absolutely. And while things like low confidence or model disagreement can be useful signals for uncertainty, these experiments clearly show that even an AI that seems very sure of itself can be wrong, especially when faced with something genuinely novel or even just a variation of something familiar it hasn't quite seen before.
It definitely leaves you thinking, doesn't it? As we rely more and more on AI in, well, pretty much everything, what are the implications when it's confidently wrong? It makes you wonder what safeguards we really need and maybe where the next big research push should be focused.
That's the crucial question moving forward. Food for thought, definitely.